Cool. Okay, that's good. So there's a bit of a delay, so I'll try and answer your questions as we go. So add something in chat and I'll try and keep one eye on the chat window as we go along. And yeah, let's get started. Because today I figured we go over the similar kind of thing that we had a look at in our workshop. And I thought it would be a good idea, actually I don't need that slide, to have a look at how we came up with these kind of images and to actually make 3 of them. So we can compare maybe the 1900s to the 1950s to 2010s, and we can get a bit of an overview. This shorter version of the presentation that I used in the workshop on Wednesday is this link here, so you can go to that and hopefully you can download these pretty easily. And on the third slide we have again the links to the things that you'll need today. So I've got this draw L system template that we can use, and there's the extra rule sets in there, and we can also have a look from the start of what we're going to need to put our projects together. So again, if you've got a question, just put it in the chat window and I'll try and keep up with the questions that come through. But if you want to code along, that'd be a really good idea. And if you have any other questions, so questions, if you guys code along, and I'll try and help you out as much as I can. So today we're going to have a look at first preparing the data that we're going to be using in the visualization, because some people have struggled with that, and which is fair enough because it can be a frustrating step. We're going to look at loading that into processing. We're going to find the sort of the minimum maximum ranges of the data that will be read by processing. We're going to select a rule set that is going to build our visualization, and then we're going to map that data to colors, and we're going to do that a couple of times. So in this slideshow I've got a little bit about the L systems. I'm not going to go over this again. This is a shorter one of what I showed in class, so there's a little bit about drawing with L systems that will look pretty familiar to you if you're there on Thursday. So it does have an explanation of how these rule sets were created. We're going to have a look at, there's some links here in the slideshow to how we draw the data, how we load the data from our CSV file, and we'll put that in processing. And there's a bit more detail about things like the function that we're using for linear interpolation of color, and also we'll talk a little bit about these custom functions and how we're using them. So let's get started. Questions come up from Olivia. For our assessment task, should we make a series of space filling curves for each different time period, or should we do one space filling curve for several decades? That's up to you. So the idea is you can draw some kind of comparison, and because these curves are like a time series, so they'll be showing a long period of time, you can get an at-a-glance sort of a proportion of each decade, right? So this is the 1950s. You can see here that there was quite a lot of blues, which in this visualization are the cooler than the long-term average, whereas the 2010s there was a higher than average. The problem with having a lot of a very long period of time is that you don't necessarily, it's not so intuitive where the start and the finish is. So if it's not a very coherent block, like a decade, that could be what causes problem. But again, you could simply try it and see what it looks like. And if it doesn't look that great, you could try, just change your data set and put it back in, and it should be able to draw something out of that. So long story short, it's up to you. and you can experiment with that, and I'd love to hear about it or see the different ways that you guys have approached this problem. So just to start off, I've got our data set here. I thought we'd start off by looking at how we get the data that was just simply downloaded from the Bureau of Meteorology website, and what we have to do to get that into something that we can read in processing. Excuse me. So let us know, does anybody have a preference for which data set we use? Because that would be a head start for someone if you want to get in there quickly. If there's no preference that comes up, I'll probably use the anomaly data, because it goes above and below 0, whereas all the other ones are just above 0. So they're a bit simpler to use. So if anybody's got a preference, they can put that in chat. But I'm going to open up Excel. I've got a zillion things open, as you can see. Actually, I need to open up the data in there. So rainfall. Do we want to look at? Let's have a look at Kakadu for rainfall, I guess, because that's a tropical area. So we have cloud, evaporation, max, mean, minimum temperature, and this one's rainfall here. So I can open this with Excel, and there we go. So this top row we have, so the thing to make sure that we understand is that all this is just a text file, so the data isn't separated us for all. Mean summer temperature, Southeast Queensland rainfall for Murray-Darling Basin. Well, there's a rainfall thing. How about I do, I won't do Kakadu, I'll do Southeast Queensland instead of Kakadu for rain. I'm not quite sure how long the delay is. But we can see that these are all formatted in the same way. This top row has a bit of information. So PCRP means it's for precipitation. This is like a location identifier in this second tab here. If I zoom in, I don't think that works. So I'm going to zoom in here. Oh, why can't I zoom in? Oh well. Sorry about that. So the this number here, this first one here, is an identification for the actual location that's measuring the data from the Bureau of Meteorology. So we don't need to pay attention to that. These are the start and end dates. So this one goes from 1895 to 2014. There's a little bit of inconsistency around these, but generally it should be from about 1900 through to about 2017-ish, depending on which data set you're using and which location it's from. This section here in the top row says that the missing value is set to a specific number. So anytime we see this 9999.9, that means that there was a day where the value wasn't recorded for some reason. And it looks like I don't... there's some at the end here. And this is... not a day. I meant to say that it's a month. So this is average values over a month. And of course the last one here is the name of the location. So this is our raw data file. I'm going to save this as the first thing. I'm going to save as... I'm just going to put it somewhere convenient, so just on my desktop. I'm just going to change this number to Southeast Queensland SEQ monthly, and I'm going to save it as a CSV file. Now, there have been some people who've had some issue with these in class. So this first, if your layout is the same as mine, you want to be able to select this UTF-8 CSV. I think in some older versions it's not so clear, and maybe especially on Windows, I think. So if you're on Windows and there's an option, if there's not this option, select the one that's comma separated values Windows. And if you're on so if you're on Windows, select the MS-DOS or Windows version, or the Mac version if you're on Mac, but this one's preferable. This is just because of the way that processing reads the file. It can cause some problems if you're not using the right format. Okay, so that was a question from Caitlin. Because our assignment is to write an article, would we be penalised if the data is old, ending in 2010 or 2013 like some of them do? Well, this is the data that we've given you to visualise, so we're not going to penalise you for that. And because you're looking at long-term trends, I think it's okay to say that this is the most recent data that the Bureau of Meteorology has. We don't expect you to go and find your own data sets for this assessment. So that's, that's fine. But you can incorporate that into your caption or into your article, that's the most recent data that we can download. Because this is just downloaded from BOM, I haven't cut anything out from this point. So I'm going to save this CSV just so I have a new copy of it. And I can see that there, and I can go to open a new tab in my Finder, I can go to my desktop, and let's clean up by date modified, and there it is there. So a CSV is like a Excel spreadsheet, but without any extra information like what color is the cell and all that kind of stuff that you can put in Excel. So that's the difference between a CSV and an Excel file. But the next thing to do is to split the data into the columns, and rain's actually a good one because it's monthly here. So the first thing I'm going to do is I'm going to clear this top row. I've still got my original data saved somewhere else, but I want to actually put headings in here that are a bit more useful for what we're going to do with them in processing. So the way that this is laid out, there is year, month, day, then a space, then year, month, day, then what seems to be a few spaces. I can move across them, so that's not a tab, and then there's the value for that specific, the average rainfall for that month. So I need to split these up, and fortunately there's a very handy way of doing that inside Excel. So the ribbon up the top, so if we start at home, we just click on data and we use the text to columns tool. And I'm going to select fixed width here because these are all lined up evenly. And if we use delimited with spaces, it may behave unpredictably. It may think some of them are tabs. And I think if there's not the same number of characters, some things get out of line. But fixed width will work because it will go to the left of this day and to the left of this date, and then the rest of it will be in the final column here, and this will get rid of all that white space. So I'm just going to press finish because those lines are there and they look nice, and it's split it into 3 columns, and so I can have a header up the top here. So this is something that's descriptive, something that's easy to type. So I'm going to put start for that date, I'm going to put end for that date, and this is our let's put av rain for our average rain. So these are just something we remember. Importantly, you don't want to put a space at the end of these, because when you save it as a CSV, that space will stay there, and when you're writing your code in processing, you have to remember to keep the space there as well. So if you're having problems, it may be worthwhile copying and pasting that and making sure there's no space afterwards, and making sure that when you're loading something in processing, it's exactly the same. So the next thing that we want to do is decide what data we want to visualize. So if somebody who's working with maybe this data wants to pick a decade, or how about we do just comparing the 1900s to 1950s to 2000 up to now. So I could keep this at the front and do 1895, but this is November to December it starts in. So how about I start from 1896? So just to get out of this, to get rid of these, I'm just going to right click and press delete, and it's going to ask me to shift the cells up. So I'm starting from 1896 and I want to go to 1906 just to have a decade. And then, so all of those, I'm going to select all the other ones. I'm just going to delete them. So you can press probably the delete rather than the backspace button, or you can right click. So this is a little 121 rows of values. So these are average values, so there's only 12 months. So 1896 January 1st to 1896 1905 to the end of December. So that should be a pretty good data set to work with. There's 121 rows counting that header, so that's 12 months times 10 years, so that's the right number. I'm going to save as, I'm just going to save it on my desktop again. You can save it somewhere, and I'm just going to put dot 1896. So that's the start of that decade. Again, you could make your own decisions here for how you want to use that. So the next thing I'm going to do is I'm going to press undo, and I'm going to have all of this data reappear. Oops. And I'm going to scroll down to the 1950s, and I'm just going to save a copy that has where am I? 1930s. I'm going to save a copy that has these values that I want in them. 1947, 1946. I'm just going to go from here back. So this is a fairly small data set. So this is pretty easy to do. If I was really pressed for time, I can right click and delete again, and it'll ask me to shift those cells up, and that's what I want to do. So I could use the search function to get to the right year. So I've got 1946, January 1st, and I want to go to 1955 and have cut out 1956. So that's January 1st, 1956, and I'll select all those, and I'll delete them. And so I've got, just double check, I've got January 1946 to here we are, December 31st, 1955. That's good. So I'm going to save as, I'm going to go 1956, and let's do the last decade. So what do we have? Up to 2014, 1130. So we'll just do a whole decade just to keep it nice and even. So that would be in no, it would be 2014, not 1994. We don't want 20 years. I'm going to select all of that, right click, and I'm going to delete, shift cells up, and let's just make sure we have 121 rows, and yep, we do. Okay, so that's 3 decades worth of average rainfall data. So this one is starting 2004, end of 2004. So we have the same location in 3 different time periods. If you wanted to, you could compare, say, 1900 and 1900 for the same variables in two locations, and then have a look at the change over time. There's a lot of different options here. It's up to you. There's a lot of questions you could ask from this data set. We've got a few different locations, and we've got a few different, if we go back to our data pack that was online, we've got a few different locations. So if you wanted to look at, for example, is Kakadoo's rainfall changing more than southeast Queensland's rainfall, you could use Kakadoo and southeast Queensland for perhaps 1900 era-ish and compare that to the modern era-ish, and you could compare those changes, so you can make some quite intelligent comparisons there with this data set. So now we have, so here's my three CSV files here. So I've got 1896, 1956 and 2004. I'm going to press space, and I can, because I'm on a Mac, it'll show me a preview, and I can see that they're in columns separately, and I'm just going to select them all, and I'm going to drag them onto this blank processing sketch that I've made. It says down the bottom here that 3 files were added to the sketch. I'm just going to open my processing preferences, and I'm going to turn up the font size for you. Hello. Hopefully that's a bit clearer for you. Okay, so there's not so many questions so far, so that hopefully means that you've been able to sort of follow along. And I'm going to have a look at what we can do to load this data into a processing sketch. So the first thing I'm going to do is press Command K, and that's going to open up this folder here. So here's my sketch. So sketch 181008C is sketch 181008C. This is the file. So this is the processing file. Oops, I only want one copy of it open. And here's in this data folder is where our CSV files live. So if we do want to make any changes, for example, if we've found that there's a problem with these headers, we need to make them to these files here, or we need to make the changes and drag them back into the folder. If they have the same name, it'll just ask us if we want to override it. So the way that we load the data in is we use a table, and we give it a name. So I'm going to call it rain data. And so I'm just going to start adding in a few things here. So this is a structure of our basic processing code, which I'm sure you're pretty familiar with now. So this is the setup. So this is all the functions that we want to do once, and we want to do them at the start. So things like changing the size of our sketch. So size can be 500 by 500 pixels, and when we run that, we'll see that our sketch window, which I think is going to appear on my other screen, so I'll drag it over here, is now 500 by 500 pixels wide. So the other thing that we would only want to do once is we only want to read this file from the hard drive once. And the way that we do that is that we tell our rain data where to look. We tell processing where to look and store that information. The function for that is called load table. Now, if you're having any difficulties with how these functions are used, you can always right click on them and select find in reference, and that will open up it's open up on the other window, so I'm going to drag it onto here. So that will open up this little description on the processing website. It's local, so you don't have to be online to worry about it, but this shows you how it is used. So the load table has quite a lot that it relates to. well, the table has quite a lot that you can do with it. So you can there's all these functions that you can run on your table, but we are only going to use a few of them, and I'm going to explain how to use them. So load table takes a file name, as we can see in this usage here, and it also takes often it will take some kind of second parameter that are the options, such as what kind of whether it's got a header row, that row up the top that gives the column a name, or whether it's got a whether it's got a whether we need to tell it what kind of file it is. So let's start off with our 1896 file. So I'm just going to copy the file name, and I'm going to put it inside this function here. I'm going to put it inside double quotes. It's important that they're double quotes, not single quotes. And I'm going to add header here. And these are going to be separated by a comma. So when I run this, I just don't want there to be any errors showing up. So let me know in the chat if you have an error when you're doing that. And I'll keep an eye out, because I know there's a bit of a lag. But we'll have, hopefully we don't have too many errors there. If you are having some errors, can you let us know, and we'll try and sort you out. So once we have this data, we need to do something with it. One easy thing that we can do is to have to count how many lines there are in the data set. So the easy way to do that is to just use print line rain data dot get row count. So in here it says we have 120 rows, so it doesn't count that header row. As we saw in Excel, it counted 121 rows, but this is 120 rows of data plus that one extra row with the header. So if we can do that, then that's a pretty simple thing that we can do to make sure that it's reading properly. So that's the value that we expect, which is a good start. So the next thing that we want to look at, if I go back to our slideshow here, so we've now prepared our data and we're kind of ready to start reading it. The reason I had the name of this file like this is I can simply put in 1956, and then I can read the next row, and we also see that that has 120 and 2004. I can have a look at, yep, they all load nicely. So that can read each different file separately, and when we get around to actually running these, we'll be able to just use those, just do that in order to create our extra visualizations. So when I go to print my lines, it says my file doesn't exist or couldn't be read. You need to make sure that the whole file name is inside the double quotes. So that generally means there's some kind of typo, or maybe you forgot to add the .csv at the end, or you didn't save it as, you saved it as a text file instead of a CSV or an Excel file. So I guess because I'm on Mac, it's a bit easier. I can see that I've got a .csv at the end there. On some Windows machines it hides that from you, but it is there. So even if you're on Windows, you need to make sure that you've got that .csv, because it won't always appear in your Explorer window. So if you try that, that would be the first thing. It's probably a typo. It's usually what happens with that error. And this is the hard part, is getting used to all the, I know that because I've seen lots of errors when that's happened, and getting used to that is the hard part of learning a lot of this code, is just understanding how to find the problems and what it means when different errors appear. So if you find some that I don't know, I'll try and help you figure out what they are. Just saved at CSV and included the full name and CSV files and .csv inside the double quotes. So it probably, did you copy and paste, or did you type in the file name yourself is the second thing, because if there's some spaces or a typo, and did you remember, because it's easy to forget, you need to drag it across onto the white area. So that's how you drop it in. See, when I drag that one over, it appeared up here. If I get another one in here, so this is the folder that my file saved in that data folder. So I press Command K or Control K if you're on Windows, and it'll open up another Explorer window, which will have, this is the processing file that I'm working on, and this is the data folder that it's reading from. So I can I'll get rid of these extra ones, and hopefully that will sort out your problem. So yes, always remember to add any file to the sketch, so it can be an image, so I can drag that over and I can drop an image in there. And to double check that it's there, on Windows you press Control K, on Mac you press Command K, and it'll open up this folder, and it should appear in the data folder there. So that's one thing to double check. So the next thing is to find the range of the data. We can have a look at this. There's a number of ways that we you've forgotten to drag the files. That's the, yes, I'm used to that error. I've done that many times. So there's a couple of ways where we could find the maximum and minimum values, because we want to map the values inside a meaningful range. So the average rain per month, I don't think there's 0 for 1 month here. I'm just looking at the whole list. Now we could, in Excel, just use equals max, maybe I won't do it on that column, equals max of this column, and it's a bit disappointing because we've got some blank values. It's got 99999.9. So, but if I change this to min, it should give me 0. So the minimum value in here is 0, and the maximum, well, there's a few ways of getting that. I can format, I can select the column and I can, I select one cell and I can filter by the cell's value. Now, and then I can, on this tiny little button here, I can just select the top 10 values. And I can also change that number. So if I've got more than 10 missing days, it'll show me all of those numbers. So we can see that there's 1, 2, 3, 4 values that have missing data, which is pretty good for a data set that goes back to the 1890s. And the highest values are 485. And of course the lowest value is 0, because the lowest average rainfall you can have is 0, so that makes sense. So we could hard code this in. We could just say our max, I'll make it a float max av rain equals 485.3, 485.3, semicolon, and float min av rain equals 0, obviously, 0.0. And so we can just create these numbers here, and because I've created them up here, they're what we call global variables, and we can use them anywhere inside our processing sketch. If I create them down here, I get a problem that these values only exist inside the curly brackets in which they're created. So setup will get to the end in here and it'll say, oh, these ones were only created here. I don't need them anywhere else, and it'll just throw them out. So we could do that with this, and if you're using something like your rainfall data, then you may want to just do that. But I'll just go through the process of calculating what the maximum values are, as some people may want to use that. So I is less than rain data.get row count. Oops. So this is just I get my typing correct. This is what we call a for loop, and this is a way of cycling through variables. So what this does is it creates an integer called I, and it starts it off at 0, and I is going to only exist in between these curly brackets here. So if we can't use I out here because it's been destroyed. We get an error message saying that I doesn't exist. So I can do something simple, like I can print I out from in here, and what this is going to do, it's going to run this over and over again until this statement here becomes false. So what it does is it starts off at 0, it checks to make sure that this is true. So I is less than the number of rows in our table, and then it runs this code, and then it increases by 1. So the first number it's going to print out is 0. Well, it's going to print out the rain data, then it's going to print out 0, and then it's going to go through again. But this time I is going to be increased by 1, so I is going to be 1. I is going to be less than 120 that we get from here. And so it's going to keep on printing out until it gets to 119, because when I equals rain data.get row count, it says, oh, that's false, and so it's time for me to move on. And then it'll go on to the next part of code. Finished setup. So here we've counted up to 119, we've got finished setup. Now this is useful if we want to calculate what our maximum average rain is. But we don't need to do that because we look up here. So rather than repeating ourselves, I'm going to create a mean average rain. Now I'm going to start that off at 0.0. So that a mean or an average, so we thought have a mean rather than an average. So the mean value is the sum divided by the number of samples. So instead of printing out I here, I'm not sure what this error is here. Oh well. Instead of printing out I, let's print the current row. So this is going to allow us to count through every single row in our data set. So the way we get the value out, I'm just going to, this is the long way of doing things, so I'm going to create a new variable called, it's going to be a floating point number, so a number with a decimal point, and it's going to be called value. And that's going to be equal to rain data.get row I. So it's going to go to the row that we've counted up to. So it's going to start at row 0, which is actually the computer's way of saying row number 1. I'm going to clear this filter. There we go. So it's going to start from the oth row, the initial row of data. And from that, I want to get a float from a column, which is titled avrain. And I want to make sure that that matches that column there. And I'm going to say I want mean av rain to have the value added on. Now this plus equals just means that it's a shorthand, and mean av rain equals mean av rain plus value. So these two lines have the same effect. So this is just a shorthand. So we're just increasing the mean average rain by the value. So this will sum up the total, and so to perform that one, and mean av rain divided equals rain data dot get row get row count, sorry. Now we're going to have a problem with this, and we're going to see why. And I've just seen a question there. Sorry, let's print out. So some people might catch up with my typing, and you'll see an error down the bottom there. So, question, Olivia said, I'm using temperature anomaly data for 1 decade. When I print the row count, it starts at 2900 and ends at 3651. What might this be? So when you print the row count, are you using you typing so your data name, such as .get row count, and put that inside or temperature anomaly data for 1 decade. When it starts, it starts at 2900 and ends at 3651. Oh, do you mean that you have blank rows before it in your Excel spreadsheet? Because you need to clear them. If you have a text editor, if I open this one, so if I get all these values and I just press delete button and they're still there, I'm going to save this as, save a copy of this, SEQ monthly test version. I close that. Arrange by date modified. So this is the one I just made. If I open that with some kind of text editor, you'll see that there's a whole lot of empty rows at the front, at the start. You can just delete all of them, and that will be fine. Mine doesn't recognize my column name, even though I copy and paste it from my Excel. So step 1, make sure you're copying it from the version that processing is reading. So Command K, go into that data folder and open up your file and copy and paste from in there. And then make sure that everything is lined out, because this is the hard part, getting all this to work properly, because it's the most fiddly. It's not the most exciting part of it, but when you're working with data, the cleaning and preparing your data is the most time-consuming part. So if you tell me, if you put in the text chat the what the error says, then if you're getting an error, if you it makes it a bit easier for me to answer those questions. But yeah, so this is the name of your table. So I've got rain data, matches up there. They're going to get row I, so get the current row. Then I want to get a float, a floating point number, so a number that can be have a decimal point, and then inside that, inside double quotes, inside the parentheses after get float, the column name, and make sure that the capitals are all the same, there's no spaces or anything like that. See, I don't see anything wrong with that code. So it should be printing out 1910. There should be, so daily, there should be like 3,651. When I print the row count. Oh, right. So when you're printing out every single row, the black console area down the bottom only displays a certain number of rows. So you've just told your computer to count up to 3,651, which is how many rows your data has because you're using daily data. And eventually that log gets so long that it'll just cut off everything before that. So that's not a problem. That just means that you're printing out a lot of numbers. For example, if I go for int I equals 0, I is less than 9, I plus plus, oops. So if I do this, basically this is just saying print out every number up to 9,000. Don't go either over 9,000. It'll only print out the last few thousand, probably 8,600, 8,503. So that's fine. Sorry, I didn't understand your error there. Error reading table on line 0. I had that the other day. So Caitlin, I think if you add comma CSV here, make sure that you're saving it as a CSV. But if you add this comma.csv, can you let me know if that works? Because I think I had that problem with a different thing before, and I think that solved it, but I may be wrong. This is not necessary if it's not going to hurt leaving it there. So if you have header comma space CSV, that may fix the problem. If not, I'll have another think about it, because I have seen that and I've dealt with it before. Okay, so our data is loaded in. The next thing we're going to do is open up and have a quick play around with our rule sets. So I'm going to find the right folder. So so you've got this draw L system. There's a link inside the this slideshow. So the LSys Viz templates, or the other slideshow that we saw in class with the more tried that, but it didn't work. Let's just open these. I'm going to open this, I'm going to run it, and then I'm going to have a look and see if I can see that error on line 0 problem. So now if we open up this L system, so this is based on The Nature of Code by Dan Schiffman. So in his chapter 8 of this book that it's got a lot of information about how to do science and processing. He's got a description of fractal and recursive drawing. And one of the really interesting things to get out of this is the way that these L systems are drawn. So this is basically what he's done, and I've just modified it slightly. So we can see here that every time I click, it increases the complexity in this L system. And what it's doing is it's actually running a set of rules to redraw a string of text. So we have, so for those of you who weren't able to make it there's a bit of information about this in the slides. So we start with an alphabet and a generation 0, an axiom, a starting position. And every time we see, in this case, every time we see an A, we're going to change it into an A and a B. Every time we see a B, we're going to swap it for an A. And so after that, we get this. So in the first generation, we just have an A, and then we redraw that to be a B, and then generation 2 becomes A, B, A. So you can see that this A becomes these two here. So this is a system of rewriting sentences. And there's a lot of different rule sets. And we create this as a visualization by using what's called turtle graphics. And this is like a really old school way of drawing computer graphics. And instead of A and B, we're going to use F for move forward and G for jump. So instead of A and B, as we saw earlier, you can go through the slides to have a look at this in more detail, we're going to have F and G. So we're going to start off at our generation 0, it's going to just be an A. We're going to just draw a line for that. So we're going to move forward and leave a line. And every time we see an A, it's going to turn into an ABA, and a B will become a BBB. Or, since we're using our turtle graphics, F will become FGF and G will become triple G. So our F moves forward, our G jumps, and our F moves forward again. And so for our next generation, this A becomes ABA, so that's a forward, then a jump, then a forward, then should be an extra B in here, where that B becomes BBB, and A becomes ABA. So then this just increases. And what happens is we end up taking the middle 1/3 out of each of these lines, because we jump as far as we step forward in this model of drawing. And so there's a lot of different things that you'll see in these, but the rules that the instructions that our turtle graphics understand is to move forward and draw a line, or to jump forward, as we saw before in these ones. Or we could, move forward and draw a line using an H, which is just a way of having a different rule applied to moving forward and drawing a line. Or we could turn right or turn left. We could save and restore the position we have here. So for example, this one that we have open by default, this shape is drawn when we click by moving forward, saving the position, turning left a certain amount, in this case it's 45 degrees here, then moving forward again, restoring that location, turning left and moving forward again by 45 degrees, turning left 45 degrees and moving forward. And so we get this tree grow. So every time we see an F, we replace it with this, and every time we see an H, we replace it with HH. So this is how this is drawn. So this is a tree, but there are other things that we have. I'm going to select all these. I'm going to press Command/ or Control/ on Windows, and we can copy these out. And so some of these, what we call these rule sets, make these fractal diagrams. These diagrams get more complex, but fill up the same amount of space basically every time we run them. So this is the Sierpinski triangle, and it just fills up this space, and this pattern becomes more and more pronounced the more times we run this. There's another fun one. That's the only standard one I've got in there. I've also included this set of extra rules, which I'm going to open in Sublime. And there's a whole bunch of these in here, and we're going to choose one of those. I don't know what this one is. We're going to copy and paste. Now we need to just make sure that we don't have two rule sets included. So all the other ones I'm not using are commented out. And we're also going to make sure that we don't comment out this bit here. We're just going to put it somewhere in between this starting bracket and this closing bracket on the Define Rules tab. Sorry, I didn't make that clear earlier. So I'm on the Define Rules tab, and I can just add in from this list here. I can just take one of this whole like paragraph here, and when I run this, we can generate a plant. That's not what I thought I uncommented. What was the one this Gosper curve, this is the one. Here we go. So some of these will fill a defined area. So this is like this snowflake shape, and every time we generate it, it fills that snowflake-ish kind of shape a little bit more. It packs it in a bit more tightly. So these are what we're going to use to draw our visualizations. So for those of you who are following along, I'm going to, you can just take one of these, copy it in, uncomment it. So you just can toggle comment off with Command/ or Control/, and press run to rerun it, and it'll be drawing with your new rule set. So while some of you at home might be playing around with that, I want to have a look at this error reading table on line 0 error. And see if I can find a solution. Because if I can recreate that, see if I can find an error. Because I minimize these and I'm just going to open this with Excel and see if I can recreate this error. So file, save as, install CSV. Let's see if that causes see if that causes a problem for me. Nope. It's hard to try and solve these errors without knowing what causes them. Extension specified for this table. Well, that's a different problem. Could you send me the file? And I'll see if it does it on my computer. This is your code. See if anybody can find a typo or something. Because it doesn't look like there's a lot online about this problem. Okay, I'll wait for you to copy your code in there. See if So I assume this is all inside your setup. Oops. So I get that running with my data file. How about, just for the sake of getting you moving on, I'm going to add these in there. So you can go back to your data pack and you can just re-download those CSV files and drag them in, and let me know if they have that problem. Are you on? And let me know if you're on Mac or Windows. And hopefully that will work, because we need to keep moving. The next thing we should do is combine these two steps. So let's say I don't want to use the Gosper curve. I want to minimize my draw L system. Let's have a look at this square curve. And I think this is kind of nice because you kind of get it's pretty easy to follow whereabouts this goes. If you were to put something like this in a newspaper, somebody would sit there and follow the whole thing through. Not that I have anything against people who read newspapers. But we can do things like we can change the angle that these draw at, and it's pretty robust. We don't really break anything. We can change the scale of the whole thing, which you may want to do, but then it doesn't really fit. So height over 5 maybe, and maybe height minus 15, just to have a look. And so the start X position is where this starts here. Could it be something wrong with class or type named rule? Where's the rule set file? Yeah. So when we copy these in, you should be in this draw L system. Oops, here we go. You should open these ones. If you're on Mac, obviously you've unzipped them from Dropbox after you've downloaded them. But you just put these inside the Define Rules tab, and make sure that you've got all these other tabs up here. We only need to worry about this other one, Make Stroke, and our first one, Draw L System, to start off with. But it should be able to run fine if you've got all of these open. So if you open any of these, it will just open this whole package of code here. So our square curve. So we can change the scale. That can be height divided by 4.5 if we want. Basically, we can decide how many steps our timeline is going to have in it. And there is a limit to how many times you can click to increase the complexity here, because some of the curves are really complex and your computer will take ages to draw them. And if we want a higher resolution version, we can just change the size. So I can make it 800 by 800 here. And because this is by our height, it'll scale nicely with our image. So we're going to have a look at 3 of the tabs here. The first one will be the Draw L System, the main tab, the Define Rules tab, and the Make Stroke tab. So they're ordered by their alphabetically. That's what I'm looking for. So we want to save a copy just in case we do something. So I'm going to save it to my desktop, draw L system stream, and I'm going to use this. I'm going to select this square curve set. Square curve rule set. Jeez, it's late. So I've only got one of these here. So if you don't have any of these rule sets selected, actually, I think that's where you get some errors here. So if you have these variables don't exist or something like that, you may have some errors come up. So you only want one of these rule sets. If you've got two of them selected and uncommented, it'll say there's a duplicate local variable. So we only need one of these rule sets. So I'm going to start off with this square curve because I think it's a bit different to what I've had a look at before. So I've selected one of these and I've just copied in. There's a whole bunch of these ones here. Some of them are really complex, like this one, but look pretty cool. So some of them you can vary nicely, such as this one here, I think. Let's start at height -10. Let's see if we can see more of it. There we go. So you can get these things, and you know, you can angle can be between 60 and 90. It says in the comment there, so I'll change that to 65. I'll just see a slightly different version of that. So it looks more like a line than that shape. So we can have a play around with these. That's kind of cool. But I'm going to stick with my square curve, I think. So you guys will be able to choose your own one. If you're going to follow along with me exactly, there is a space in the rubric where you'll fit. If you simply choose a different one and choose some different colors and choose some different data, then you'll get a those are the things that you can use to make yourself stand out from what we've done here, and that you'll get the extra marks that you deserve for that, for making those changes and making those decisions. So here's our nice half square. Let's have a look at actually combining this with our, so selected rule set, combining this with our data. Now the way we do this is I've got a copy here, so any changes I make, I've still got the original to go back to, but I'm going to close my extra rule set and I'm going to drag in my 3 decades of data that I want to look at. So down the bottom here it says 3 files added to the sketch, so that's confirming those have been added. I can press Command K and I can, there's my files down here, and this is this copy, and I've got these 3 data files inside a data folder. So processing will be able to find them. Then I need to do basically the same thing that we have here. So I'm going to be a bad programmer, and I'm just going to copy and paste these. I'm just copy and paste. Firstly, these are called declaring variables, when we just say that we want this to exist. So we're saying processing, get ready, I'm going to eventually give you something that is a table, and it's going to be called rain data when I refer to it. And then these are declaring and assigning the values. So the assignment is the equal sign. So it figures out what's on the right here. So if this was a little math equation, it'd solve that, and then it will just put it into here. So we're declaring on this side, and we're also assigning by having this equals on this side. And of course everything ends with a semicolon. So I'm going to take these and I'm going to just copy these over here before the setup. Okay? So these, because they weren't created inside any curly brackets, like here, actually like value is here, so value doesn't exist once we get outside of this for loop. So each time value is recreated and cleaned up, they say, So we can't use value down here, but we can, because our mean average rain is up here, it's created up here, we're only just changing its value over here. So we can use that anywhere in our code. So that's what we want to do. So that's why we've got those outside our curly brackets. Then inside the curly brackets, we just want this bit here. So we're going to go from loading our table, printing our row count, calculating our average value, so our average rainfall, our mean average rainfall will be calculated, and then it'll print it out at the end for us. And I just want that inside the setup somewhere, as long as it's not before this first size. It can't be the first thing, nothing is allowed to go before size here. So I'm just going to paste this in here, then I'll tidy it up because I'm a bit pedantic about my code, and I'm going to leave a comment for me. So load the data, and down here I'm going to add a comment, calculate the mean average rainfall. And then here we have end of setup. So this is all going to happen once. So we only want to load the data once. We want processing to load it and keep it, and we don't want to figure out the average rainfall every time that we redraw our image. We only want to do it once when we start the program. So when I hit run, it does all these things once when we start the program, and then it runs this draw function. Normally it would run over and over again, but in this version there's no loop, so our computers don't come grinding to a halt when it tries to draw thousands and thousands of tiny little lines like this. It would slow it down considerably. So, but we don't need to change anything in the draw, we don't need to change anything in the bottom down here. We just want to add, again, we're declaring our table and our variables that we want to have everywhere before the setup, and we want to get our loading data and our calculating mean, our little algorithm there, our little set of instructions to do that. We'll get those inside the setup. So that's all we need to do. So I'm going to save a copy. I've also got my rules defined here, and under the make stroke tab we have what's called a custom function. This is a custom function is, well, any function in processing is basically a little block of code that you can run at any point. And I'll just quickly go over some of the notes I had for this. So a function is like a named block of code. So for example, some of these are hidden, like the size function. This is a named block of code. It's called size. And it takes, in this case, it takes two parameters. So you separate your parameters by excuse me, my burrito's not agreeing with me. So you separate your parameters by a comma, and so this is the width and this is the height that we want to make our canvas to draw on. So load table is a function, print line is a function. So these are all little packages of code that we can reuse and rerun anywhere we like. And there's lots of functions that are very useful. So we have things like our rectangle function, so an X and a Y position, then the width and the height of the rectangle. We have our line function, which has our start and our endpoint for our line. So an X and a Y coordinate to start a line, an X and Y coordinate to finish a line, and then it'll draw the line in between. It'll turn all the pixels whatever color they're supposed to be in between. So I've included color mode here because it's changed. We don't need to worry about this one. We just need to accept that that one's there. That's just another example. And we've got things like lerp color, which we'll use. And this returns something, so it gives us back a value. So we can say, have this lerp color on the right hand side of an equals, but we can't have a rect on the right hand side of an equals sign because that doesn't give us any values, it just draws something to the screen. Now, when we're making custom functions, we have this void thing. So let's have a look at this function. I'm going to copy and paste it from my processing sketch. I'm just going to cover up all my other processing sketches with this one so you don't get distracted. So my gimme donuts function, if I run this, nothing happens. but it runs. I can show you the little sketch window just to prove it. Come on. There you are. So I get this empty box coming up and nothing happens. But if I put in, if I want to run this function, I need to use setup and draw. So let's just run it once, so we don't need our draw function, we'll just have our setup function. So I can say, give me donuts, and give me 10. And then it'll say, thank you for 10 donuts, friend. It's very nice of it. So this is what we call a custom function. So we've given a function our own name, we've told it how many and what kind of variables we expect, and we can use that variable inside these brackets here. So when I run gimme donuts 10, it's going to say thank you for, and it's going to find this input, and it's going to look at it and it's going to say, oh, that's 10. So it's going to have thank you for 10 donuts, friend. It's a very nice function to run. And so because it doesn't return any values, we have void at the beginning here. So that's why void setup has this here, because it's a function that doesn't return anything to any other functions. It just has something that it does. Whereas if we want it to be some kind of number, so for example, I'll just paste in my share donuts. I will have like float leftovers can be equal to share donuts 10. So if I'm going to share 10 donuts, I can then, with this function here, it's going to take the input, divide it by 2, and then it's going to say you get this many donuts, buddy, and it's going to return this value to me. And then let's go print line I have leftovers donuts NUTS leftover. Okay, so it says thank you for 10 donuts, friend. That's this gimme donuts running. And then when we run leftovers, this share donuts runs with 10 donuts. So it divides it by 2, and it says you get this many, and it returns that value that we calculated here, and I can print out and use that later. So that's a little bit about custom functions. So they can return a value, or they can just return nothing and we have void there, but they can do things at any point. So the difference between a function and something like a loop is that a loop will run a certain number of times immediately. It won't wait for anything else, whereas a custom function will actually allow us to run it only at certain times. And this is how we're going to use that in our L system. So if we go to this, I'm just going to show you, you don't need to do this, but this is a little bit, this complex little series of if statements. So every time in our rule set our turtle sees a F or an H, it's going to draw a line. But we want to run our make stroke function. So this is our custom function that our code is going to run. And we're saying we want a number, and it's going to be an integer, so there's going to be no decimal point. And we want to just you to give that to us. And so I've made it so that every time it draws a line, it increases that number. And we're going to use that to read from every different line inside our data set. So the first time it's going to start off at 0, so we're going to get row 0, the top row, and then it's going to go to 1, then we're going to get the next row down, and then 2, and so on. And so what we want to do is have some kind of value of some kind, so our data that we're reading from our file, that can be equal to what did I call our table? I think it was rain data. Rain data. Data.get row, and I want to get row count. So which is this one here. And I want to get a float from that table, and the column I want to get, can't remember exactly, but it was, I think it was called have rain. No capitals. And let's just print out value. So we would expect that each time we run this, it's going to print out, a couple of times it's going to print out the rows. So down the bottom here we have, so that's the row 0, it's the top row in our data set. When we run it again, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, I think, lines. So it's printed out 133.5 again, so it's printed out row 0 again. Then it's gone to the next couple of lines. So it's, these lines aren't attached, the data isn't there, it's just that we have an opportunity to kind of step in and quickly say, let's draw, let's do something with this value in between. So now I have access to the data that I would like to use. And I can do a lot of things with it. I can just use it as a variable. So I could do something like, the way I've placed this is that we're going to update the color of the line based on that. So I can have a stroke from value, because it's just a number, we give stroke a number. So we can see that this one here is pretty high. It's 331, so that should be pretty much white. Oh no, sorry. I should say, to make playing around with colors easier, my color scales goes up to 360. I'll explain why in a little bit. So this one's almost white because a single value for our colors are grayscale. We could do that, or we could have a stroke weight being value. So we'll have some really thick lines and some kind of thick lines. We can see how they change. But eventually, let's change it back to our stroke instead of our stroke weight. Eventually, we get a bit of a problem because there's only 120 lines in this particular data set. So that's not a lot. So what could we do? We could say, if the count is higher than the number of rows that we have, do something different. Okay? So we remember from helloprocessing.org, and you can go over helloprocessing.org if you go to that website if you haven't yet. We can have an if statement, and I want to enclose all of my little algorithm for calculating the stroke within that if statement. And so the if statement means that this section, this block of code between these brackets is called a block. This will run if the condition here, so some little statement here is true. So if count, the value, the row that we want to look at, is less than our rain data.get row count. Oops, don't need it. Don't need a semicolon there. Don't need a semicolon at the end of this line at all. So now I should be able to just keep drawing. So here we go. So we only have the first couple, and we can see that it gets down to here somewhere, and then it's run out of lines that it needs to draw, and that's fine because we only have a fairly small data set for this one. So I think this is probably the last value we have. So what are we able to do with this? Well, we could do a few things with this. We can create a little algorithm, a little set of rules for the way that our stroke is drawn. So I'm going to keep my value. I'm going to keep printing my value, but I'm going to remove that. So one thing we might want to do is have one color for if the stroke is higher than the average, and one color if the stroke is lower than the average. Okay? So if value is greater than my average, was it average? Mean average rain, mean av rain. Then I want to do something in here. So I can print line above average, and we could run that. Now I'm not going to use an else statement in this because see, we have 331.4 is above the average, 133.5 above average, because the average rainfall is only 59, and that's in millimeters. Now I don't want to bother with an else statement, because if it's above average, will a flower pattern rather than typical quadrilaterals be appropriate this project? So the question from Polly has come through about what do we want to use for this project? Can we use a different pattern? I'm going to open, I want to double check with the assignment rubric, so I'm just doing that on Canvas at the moment. There it is. Rubric. Okay. Blah blah blah. Rubric. So image. So the rubric says you've designed a novel image that creatively represents data and facilitates insightful comparisons. So we're giving you the L systems for you to use because we think they're a bit of fun and something different. Has a bit of connection to biology because it was originally done by a biologist. But you don't have to use this one. If you want to use a different code that you've gotten from a different semester or a different template that you've started with, or you can find some other templates online, then you're more than welcome to use those. I just wanted to double check with the rubric to make sure it didn't say specifically you had to use this template. So yes, you can. You can go through some other code if you want to come up with something completely unique, and that'd be really cool. But you just have to create it. You just have to create it based on some data. So yeah. But we're kind of near the end of this process because we have value is less than the mean average. We want to do one thing. We can make the stroke be one color, and I'm just going to go up to the tools up the top here, and I'm going to use the color selector. And I'm just going to choose a color. So if it's above average, we want it to be like a rainy blue. And I'm going to use these first values here because these values look really nice, especially when we start to interpolate between colors, which we'll get to in a few minutes. So I'm going to use 220, 83, 95 for my values here. And so all the ones that are above average are here, but rather than having an else statement, I'm just going to set the stroke to a different color. Actually, yes. So the stroke will be, let's make it a drier color, a warmish kind of yellowish kind of color. So 50, 57, and 99. So remember these first three numbers in our color picker here. So we have a threshold. Yes. That is true. Somebody's got I saw another comment there. Polly said, "Thank you, Phil." That's fine. Using different colored flowers to represent temperature changes over time would work. Yes, that would work. That might look pretty cool. You could have like browner flowers for ones that have less water in them, and yellower or pinker flowers or whatever. you could use some randomness to figure out what the flowers are. I don't know. So Angelica says, I've got an average rainfall of 894.96. So you're probably using one that obviously has those really high numbers that indicate that there's some data that's not supposed to be there. So I'm going to show you how to get rid of that. It's pretty simple. So we go back to our main tab here, our draw L system stream on my one, but you will have named your first tab something different. And inside the setup, we've got we're loading our data, we're printing our data, then we've got our for loop where we're calculating our average. I'm going to add one line of code here. So if value is less than the 3000, so some arbitrarily high number, but remember that especially if you're doing in some of the tropical regions, it's I don't know whether average will get over 1,000, but so over 3,000, probably they don't get 3 meters of rain in a month on average at any point. So if value is greater than some large number that's smaller than that 999, then we add the value. Now, if we wanted to be really particular, what we would then do is we would then count those numbers and we would reduce this number here by that amount. But we're looking at like 3 rows out of 120, so the value isn't going to change very much. And our average value is just a threshold for us to change colors, not our minimum and maximum. So I'm not going to bother with that. If you want to add that in, that's fine. But this should be able to stop your average from being really high when you have those times that have way too much of the rainfall data. And remember that our maximum here is figured out from our Excel file. So this is the maximum average rainfall over a month for the entire data set. Whereas here we're calculating our mean is just for this decade. So we could figure out the mean for all of them pretty easily using Excel, or even by loading in all the data in and just running this for loop at the start and getting that value, because it's not going to change. It'll be different for each decade. So we could say that the means are also getting higher or lower, as the case may be. So we have, going back to our little algorithm here. So for our algorithm to decide what color to draw our lines, we're saying, okay, let's first check and make sure that the number that we're showing, the number that we're trying to read, is a number inside our data set. And if it is, we're going to run this section here. So the first thing we're going to do is we're going to get the data, we're going to print it out, and then we're going to set the stroke. And if that value is above the average, we're going to change it. So this isn't going to have cause any problems. This is really fast. It's not going to slow down your computer or anything. But we don't need to have extra if statements which cause a bit of overhead. So the other thing that we need to do is let's make all of the other lines that aren't within this rain data.get row count to be stroke 0. So we'll make those lines black. Could you advise using temperature anomaly data rather than regular temperature data to show overall climate change? Yes. So questions that just came in. I'll just run this so we can see what happens. Just to finish that thought that I was on. So we can see here that this line, this blue line here, where my mouse is it gonna, is the last one. So these ones here don't actually have any data here. So why don't I'll make that the same color as the background, 360 for white when I'm in this color mode. So we can see that this is the only part of the shape that it's drawing, or it appears to be drawing. Those lines are there, but they're just the same as the background. Okay, so we have the first thing we do is change the color to white. Then we say, is this row part of our data set? Yes, then we'll change it to this yellow color. Then we say, is it above average? Then we say, actually, we'll change it again. So there we go. So this is a pretty simple data visualization, but it is visualizing the data, whether it's below or above the average. Now, do you advise using temperature anomaly data rather than regular temperature to show overall climate changes? The anomaly is useful because it's in relation to the long-term data. What I mean by that is it makes it very easy to see where this middle should be, because the temperature varies so much that across the year there's a lot of variance, right? Summer's hotter than winter, obviously, except in the tropics where it's always hot. So comparing it to the long-term average is actually very useful. If you really want to show climate change, you would show the minimum anomaly data. That has the greatest variance, because the minimum daily temperature has what's seen the biggest change, because those hot days, they don't increase their temperature as much as the minimum temperatures have increased. So it would be that would give you the greatest visual impact. Next question, would it be preferred for the assignment that we use processing to find the mean, max, minimum, etc., or can we use Excel and code that in? You can use Excel. It's up to you. That's fine. You're not submitting your code, just the images, so you can use whatever's easiest. And Caitlin, is it possible to code for a gradient color change? Actually, yes, and I'm about to get onto that. So the higher above the average rainfall it gets, the darker blue it is. So let's have a look at, let's just do one color and then we'll add in two colors. So I'm going to comment out this so I can keep it for later. And let's show a gradient. I think it was LERP color code. Yes, it is. It was covered in the practical, and I think you'll be covering it later. I'm covering it right now. So what is LERP? So LERP is short for linear interpolation. So if you have two values, such as 0 and 20, if you want to go 75% of the way from 0 to 20, you'll get 15, right? My maths is right, yes. If you want to go 10% of the way, you'd get to 2. If you want to go to 50% of the way from 0 to 20, you get to 10. So that's an easy way to start off thinking about linear interpolation. So it finds the proportion of the way between two numbers that it is. If you go over, it just gives you the top value. Okay? So you could have a threshold, say, if it's over 50 millimeters of rain a day, just make it this color, but you want a gradient below that. So you could have like 0 to 10 and then greater than 10. LERP color uses some kind of sorcery inside processing. I'm not quite sure how. I could, you probably could figure it out or look it up if you really wanted to. But basically what it does is it does the same thing, except instead of using two values, it uses two colors. So you could imagine if I had two colors, 2 points on a chart, so a Y position and an X position, and Y position and an X position here, you could figure out the distance between like 3/4 of the way from this point to this point up here. It'd be somewhere here. If we had a three-dimensional space, so I've got a X position, a Y position, and a Z position, and an X position, a Y position, a Z position for two different points, you could imagine that it's like that. You can get that far, 75% of the way between those 2 points. Basically, I think what it does is it converts the colors to 3D space. So on scales of 255, probably. That's how I would do it. So you can find something that's a certain number of steps towards another color. And because it's color, we get to see it visually rather than think about it abstractly in spatially. So let's have a look at how we would do that. So let's set the stroke to be, let's start it off at a rainy blue. Let's 213 57 99. Okay, so let's say that this is the top of our scale, okay, and rather than just setting that as a stroke, I'm going to save it as a color. I'm going to call it our 2. So what I've done, instead of creating an integer or a floating point value or a table, I've created a color and I've called it 2, as in to go towards. And I've used this function, and this function is one of those return functions that gives us something back, and it's going to give us back a color. So processing understands what this is. All we need to know is that every time we refer to 2, it's referring to this color. And I also want a color called from, and that can be, let's have something kind of dry and sad looking. 47, 60, 79. And so this is going to be our 0. Okay? So we can have our, so we have our 2, our from, and our value. What we can now do is figure out our amount, and that will be a float. We need that to be a number, and it needs to be between 0 and 1, so it has to be a decimal point. So I'm going to get my value, and I want to find that as a proportion of our total. So I can divide that value by this maximum average rain. Okay, that's why we need this one here. Oh, whoops. And I need to finish that thought by actually typing it all in. So I'm going to have a float. It's going to be called AMT, short for amount, and it's going to be equal to whatever my current row's value is, which I loaded up here. And when I divide that by the maximum average rain, that will give us that proportion. But let's just protect ourselves from these errors. So if our value is greater than 3000, again, that's the only time we want to update these colors. Okay, so we can have, I'm going to tab that in so it's a bit prettier. So this section here, this will only run if our value is not one of those days where it's missing. So, and the float has anomalies. So I'll show you that as well. I'll just do this. So this is only one scale, so this is a bit easier. The anomalies are a little bit different. So, and I'll show you where you can, what you need to change to do that. So, to figure out what color it should be, we just have a stroke. Sorry, let's have our color Australian spelling equals lerp color from to amount. So it's going to go take from this color to this color by this amount. And so the order has to be like this. And then we'll have stroke color. Now I'm going to use my Australian spelling there, and I'm going to change the stroke weight to, let's say, 3 pixels, just to make it a bit more obvious. What have I done? Oh, sorry, I had a greater than instead of a less than here. So that's why nothing happened. So I can see here that we've got a bit of variance there. And when we get here, these lines are being drawn white, but it's closing off that triangle. So let's just draw those as black instead. just so we can show a difference. So this is a single color scale. It's not a very good color scale. These colors look horrible together, but you can change these values for from and to, or to and from. And so this is showing one scale. So 0 will be down here, and higher numbers will be up here. So this value here, let's restart that. This value here is one of those higher values, and this second line here was quite a high number as well. So what happens finally, I think, what happens if we have a threshold that we want to have two color scales, two color scales, one above and one below, and we just need another if statement. So inside this check here, I'm going to make sure, so if the value is less than 3000, so it's not a missing day, we're going to have another if statement. So if our value is less than, let's say in our case we have was it mean average rain? It will change to that color scale. And rather than dividing it by our max average rain, we need to figure out a new value for this amount. So there's a few ways we can do this. I'm going to show you two ways. So amount can be map from, I want to map our value from 0 to 1, sorry, mean av rain, max av rain 0 to 1. So what this function does, is going to stretch. We're going to use this map function. This is one option. So we're going to take the value, and we're going to say it's from the average to the upper value. So you could be, have it as 0 to the maximum value if you're using your anomaly data, your temperature anomaly data, and it's going to squash that down from like 0 to, from like 50 to 400. It's going to squash that down there. Or the other way we could do it, so that will give you uneven values, right? So this is like over the average and below the average. That's one way of doing it. That would work perhaps for, you could say this value could be coded in as 100. So 50 to 100, or whatever, our average rainfall is 59. So 59 to 100 is this value. But anything greater than that, because it's greater than 1, will just give us this top number here. So if we give a value of 2 to here, or 3 for the amount, that value 2 stays the same. It doesn't, the colors don't go further than that. So that's one way of doing it. Another way to do it is something like by just using a little bit of math like this. Float max average rain minus mean average rain, or something like that. How would I do that? I'm going to leave that one there. So float amount equals value minus mean average rain divided by minus mean average rain, and they should all be in brackets. So that will kind of offset those values down, and still have it. So there's a few ways you could do it. You could have it set to You could have like a ceiling value that any more than 100 mils will just be the same color, which would happen here, or you could kind of calculate it manually that way. So there's some options for you. So if the value is under this, over the average, I had a typo there. If the value is over this much, we're going to run this code, and our to and our from are going to be the same, but our color, let's use this value here. So it's going to go on a scale from the average to 100, and if it's over 100, it's going to give you a larger number for the amount, but the color is not going to become any more blue. And then here we can use our else. Then we'll have stroke 0, 100, 100. So I'm just going to have that as red so we can show that there's some that are different. So this is our blue one here, so it's above the average. These ones are all below average, and here we have some that are above and some that are below. So let's change our to color to like a kind of a gray, a coolish gray. It does actually matter. 209. Oh, actually, we could go 213, 0, 99. For the map function, what do the 0 and 1 in the brackets mean? That's a good question. So in the map function, I'm going to right click on this and I'm going to find in reference, and it's going to appear on my other screen. And what a map function does is it takes, so this is the syntax for this. So this is the reference page. So I can right click and select find in reference, and that will show us where it, how to use it, and give us some examples. So it takes the value that we're going to stretch, that we want to change. So our, so in this case we've called it value, and it says it's originally starts on a value on a range from here. So we could say it's between 0 and 10. And then if we want to say we've got a value, we've rolled some dice and it's originally from 0 and 6, and we want to change that to a number between 0 and 100. So our dice number that we rolled, our value, is originally from 0 to 6, which is this pair of numbers here. And we want to stretch that out to 0 to 100, or we could stretch it into 0 to 1. It doesn't matter. The code is able to deal with both of those. So we have start 1 and stop 1 are our input values, the value's current range, and this is our desired range. So it's on. So it'll change to a scale of, in our case, we want it to be on a scale of 0 to 1 for this lerp color function, because that amount value should be on a scale of 0 to 1. Yeah. So we have. Back to our code, we've got this working. So these red ones here are the ones that are below our mean average rainfall amount. Okay, so all the other ones that are not errors, not below the average rain count, let's do a similar thing. So I'm going to have it be an Ackery kind of color. Oh, sorry, I changed that color, but I didn't actually rerun it. 213. So this value, and let's say they're going to go down to, let's say 16. Or 15, so it'll be a nice pale grey. So that's kind of on one scale. So you do need to kind of fiddle around with these numbers a little bit to make sure that they go from the color you want to the color you want without going kind of around a corner and turning greenish or something like that. So That's the ones that are above the average. The ones that are below the average, let's get a different pair of colors. So I'm going to remove that. I'm just going to have my color 2 equals color brackets, and let's have more accurate than that. 150, 83, 99. 150, 83, 99. COLOR. And I want from color, and I want that to be, let's go down there, color 150, 15, 99. Okay. And our amount, we need to figure out what that is. And that can be, let's use map again, just to practice that. So I want to take my value, and at the moment it's from a scale of 0, because that's the minimum amount of rain I can have. So if you have figured out, if you use something similar here, so you've got your minimum average rain from Excel or from in here, or your minimum anomaly data, you can just have that coded in here. So you could go from actually I probably should go, I could go from minimum average rain, which I know is 0, but I'll use it anyway, and it's on a scale to the mean average rain because it's below that value from this if statement, and I want to stretch it to it from a value from 1 to 0. And the reason is that we're swapping it round is because when we do color equals lerp color, American spelling, from to amount, oh sorry, missed a comma there, and stroke color. This is what we need to do because we want the from color to match the highest value rather than the lowest value when we're going down the scale. And so now we have a gradient showing the change in those variables. So we could have these going back to the same number. For example, let's say we want them both to go through a yellowish kind of color. Let's say 61 for our from for both. Then they'll kind of have this, the blue and the green will both diverge to the same color. So that could be kind of a silvery grayish kind of color, which is what I used in my example in here that you can see. So all the days, whether it's slightly above or slightly below the anomaly, so the values were close to 0, they would both be silver, whether they're a fraction of a degree above 0, a fraction degree below 0. They'd still look that kind of silver color, which is why this is kind of bland and silvery looking, but you see more intense colors in the later decades and in the blues in the early decades. So now we have it. That's what we need to be up to. Maybe we could have a look at, you could experiment with some different curves and see how they look. But from here, all we need to do is say, oh, I don't want to, I'll save this. There's a couple of ways of doing it. The easiest way is probably taking a screenshot. You can add a line of code that says save, and then give it a file name. So test image.png or JPG. You could add that in if you want, and just every time you draw this, it will save over that same file, which we can see if I open up the right window, so here's our image. So when we rerun this, it's just going to write over that. So we can see here that, come on, it doesn't enjoy being written over so many times. I run this again. Oh, it's because my desktop is syncing to iCloud. It's having a bit of a spaz. So we could run it there, and every time we re-render it, it'll just save the image once it's finished. Or we could just take a screenshot. Either's fine. But once we've decided on that, we decide on which rule set we want to use, and we save our image, and then we just select a different decade because we were clever about that when we named our files. So we can look at 1956, and we'll just load the next files. So there's a lot more greens there, I think. Whoops. Oh, I've removed. Where's my... 2004. And then we run this one, and we just run them again. We can see there's a lot more green in this one. So showing those next to each other is where we can make those comparisons. And we can see here that we've got those days that are missing, and that's fine. But we can see that we can make those comparisons fairly easily once we put those side by side. It's a bit difficult. And again, if we're going to just have the save function in there, then we can just have those as... we just need to take them out again and rename those files, because they'll just save over each time. Or you could just take a screenshot. So then all we need to do is stitch them together, or place them in your in Word or whatever, and when you make a PDF out of that, then you can, over the top of it, add a caption. You don't need to Photoshop these together, but you do need to submit it as a PDF, and when you submit it as a PDF, it'll look the same for me as it does for you. So we can we'll be able to see your caption and things like that nicely, and you can organize them. So I think that's all we need to look at today. So I think that went pretty well. On Canvas, I've got a discussion forum. So if you've got some more questions, or you've still got some issues that you're having, you can go on there. But thanks everyone for hanging around. Hopefully this will be helpful for you. Everybody will be able to have a watch. Hopefully most of the questions that you've asked will be ones that somebody else has had. How about I add this file to our oh, that's a different folder. To our processing folder that you guys have access to. So you can see what I've done. And so if you go back and, oh, thanks guys. I'll be in contact via an announcement or an email to everyone during the week, probably, to see if we want to run any drop-in sessions and when's best to do that. But again, I'll check the discussion board every day. So if you're having problems, paste some code there, and let us know how you're going. And I'll see you around. And I'm just going to turn off my stream and see you later.